Okay, good evening. This is Professor David J. Tilasuyas. Okay, it's October 26, 2023. The time is around 10:02 p.m. Okay, my topic for this session will be a continuation of my long video format discussion, and this is actually the study of trigonometry. And I am now on lesson, or we are now on lesson number 11. Okay, let's proceed. The subject matter for tonight will be trigonometry, lesson number 11, and the title of the topic will be the right triangle. Meaning, this will now be the concepts on how to solve the parts of the right triangle that is under the study of trigonometry. So trigonometry is actually related to triangle. Okay, triangle, trigonometry. Okay, because the definition of trigonometry, it is actually the study of triangles with all its angle inside and all the sides. That's trigonometry. So for tonight, it will now be the solution of a right triangle. Okay, presenting the 5 cases that might come out. There are 5 cases that might come out for the solution of a right triangle. Okay, what is a right triangle? A right triangle is a triangle in which the acute angles inside, the sum is actually equal to 90 degrees. Okay, we are given angle A and angle B inside. Okay, and the sum of these should be equal to 90 degrees for it to be a right triangle. Oh, this is an easy one. Okay, let's try to bring out the solution of a right triangle. Meaning solution, there are parts of the triangle which are given, and what is being asked is actually the other parts. Okay, usually the usual case is that actually we are given two parts of a right triangle, and we are asked to find the other parts. So it depends on what part is given. Okay, for case number 1. Okay, we are given an acute angle A and hypotenuse C. Oh, this is an easy one. Just draw a right triangle. Okay, acute angle A, angle B, side A, side B, side C, and this is angle C. And for it to be a right triangle, angle C should be 90 degrees. Right? For case number 1, what is given is angle A. We are given angle A. And we are given the hypotenuse. Okay? So what is being asked is actually, we must have to compute for the value of B, meaning the angle B inside. We are given the hypotenuse, so opposite side A is unknown. Oh, this should be question mark. And adjacent side B is also unknown. So for case number 1, what is given is actually angle A and hypotenuse C. The problem is asking for case number 1, what will be the value of angle B, what is side A, and what is side B. For angle C, we don't have to solve it anymore because for it to be a right triangle, angle C should be 90 degrees. Okay? So this is given. Okay, let's try to bring out the solution. If we know the value of angle A, okay, angle B should be equal to 90 degrees minus A. Because for it to be a right triangle, angle A plus angle B equal to 90 degrees. So if we are given angle A, angle B should be equal to 90 degrees minus angle A. Okay? It is just a plain subtraction. Oh, what's next? Okay, we are given angle A, right? We are given the hypotenuse. So if we try to solve for A, think of the relation of side A with respect to hypotenuse C considering angle A. Okay? That is one of the definition of the trigonometric function. The relation of side A and hypotenuse C considering angle A is the sine function, right? Sine. So sine of angle A, the sine of this angle here should be the ratio of its opposite side over its hypotenuse. So it should be the ratio of A over C. Okay? Angle A is given, side C is given. So if we try to compute for A now will be equal to the hypotenuse times the sine of angle A. Okay? Let's try to compute for side B, the adjacent side considering angle A. The relation of B with respect to C is cosine, right? Considering angle A. So if we try to take the cosine of this angle A, it should be adjacent side B over hypotenuse. So this should be B over C. Angle A is given, hypotenuse is given, therefore side B, adjacent side B, should be equal to C times cosine of A, C cosine of A. Okay? We got all the parts already for the right triangle, so we solved already the problem. Right? So, to solve for the unknowns, okay, just think of the so-called relation of the unknown, of one unknown with respect to the other given part. And apply your knowledge of the so-called definition of trigonometric function. Like this one here. If we are given as hypotenuse C and angle A, to compute for A, the trigonometric definition that we will be using will be sine, because sine of angle A will be this side here over C. So A now will be equal to C, sine of angle A, if we try to simplify this one. Okay, it's an easy one. Case number 2. Case number 2. We are still given acute angle A. Okay. And opposite side A. Meaning we are given angle A and we are given opposite side A. First case is actually we are given the hypotenuse. That's case number 1, right? But for case number 2, what is given is actually angle A and opposite side A. So the problem is asking what will be angle B equal to. What are the other unknowns? It should be side B and side C. And what will be adjacent side B? And what will be hypotenuse C? Okay? So we are given 2, actually 3, because angle C is 90 degrees. We are given angle A, side A, so we are asked to compute for the value of angle B, hypotenuse C, and adjacent side B. Of course, if we are now given angle A, angle B should be 90 degrees minus A, because the sum of angle B plus B is actually 90 degrees. So this is the value of angle B. Okay, what's next? Supposing we'll try to compute for A. C. We'll try to compute for C. Considering hypotenuse C, what will be the relation of hypotenuse C with respect to opposite side A considering angle A? It's still sine, right? So if we try to take the sine of angle A, it should be A over C. So this is A over C. Okay? But what is given is angle A. What's happening? A and side A. So if we try to compute for C, or algebraic manipulation, we cross multiply this one, the product of sine A times C will be equal to A, or C will be equal to A over sine of A. It is this. Right? You can transform this one to be A over cosecant of A. But actually, you cannot compute for the value of cosecant of A from the calculator because the calculator only involves sine, cosine, and tangent. So I think it's better to we use this one here, that is A over sine of A. Because if we try to use our calculator, we cannot find cosecant over here. No cosecant. So it will just, I think it's more than good enough that we'll compute for the value of sine of A. We'll just divide that to the value of A so we could compute for C. Right? Oh, what's next? If we try to compute for side B, okay, what will be the proper, what you call this definition? We use tangent. Tangent of angle A will be A opposite over adjacent. So tangent of angle A will be A over B. We must have to compute for B. So B will be equal to A over tangent A. Right? We are given A. We are given angle A. We could take the tangent. We divide that value to the value of A and we could compute for B. Okay, we know C and we know B already. Okay? So just take it easy in the so-called formulation of the equation on how to compute for your node. Just apply your knowledge of the so-called definition of the concepts of trigonometric functions, right? Okay, case number 3. Case number 3, we are given an acute angle A still. Acute angle meaning angle A is less than 90 degrees. And adjacent side B. Case number 2 is opposite side, what's given, right? But for case number 3, we are given angle A and adjacent side B. So we are given angle A and adjacent side B. So the problem is asking what will be hypotenuse, what will be the opposite side, and what will be the value of angle B. Okay? So we are just rotating, right? So if we know A, we subtract that from 90 and that will be the value of angle B. Right? Okay, we are given, what's given? Okay, I will try to erase the correct. We are given angle B. Okay, we can now compute, we can now take the relation and to solve for the value of C. We use cosine, right? The relation of B and C considering angle A is cosine. So cosine of angle A, the cosine of this angle here, it should be its adjacent side over its hypotenuse. So they should be B over C. Okay? So if we try to compute for C, we are given angle A, we are given adjacent side B. So C now will be equal to B. Cosine will be underneath, right? It will be B over cosine of A. We are given angle A, we are given adjacent side B, so we could compute for the ratio of B over cosine of A, and that will be C. You don't have to memorize this. Since I am teaching, I am just showing you on how to derive the proper solution for each case. Okay, we'll try to compute for, we now know C, so we'll compute for A. Okay? And the relation of A with respect to B will be tangent considering angle A. So the tangent of this angle here will be the ratio of its opposite side over adjacent side. So tangent of angle A will be A over B. And if we try to compute for A will be the product of B times tangent A. It should be product, right? Because we are solving for A. What is given is adjacent side B. Okay? Okay, that's the solution for case number 3. This is now the value of B, 90 degrees minus A, and C will be B over cosine of A, and A will be B tangent of A. They should be product and they should be ratio because what is given on the tangent is actually B, and we are solving for A. So A will be the product of B times tangent A, or this is B tangent A. Okay, case number 4. So we are just bringing out the different cases in which a problem will put, right? Case number 4, we are given we are now given for case 1, 2, 3, we are given acute angle A. So case 4 and number 5, actually we are now given the sides. No more angle given, right? So for case number 4, we are given hypotenuse C and side A. Meaning we are given the hypotenuse, okay, and we are given side A. We don't even have to say opposite side A, because for the meantime we are not given an angle for case number 4. We are just given two sides, hypotenuse C and side A, right? So the hypotenuse is given, A is given. Of course, what is being asked will be angle A. What will be angle B? Okay? The third side is adjacent side B. Okay? So we are given hypotenuse C and side A. What is being asked will be angle A, angle B, and side B. Okay, let's try to compute for angle A. The relation of A and C, considering angle A, will be sine, right? The sine of this angle will be A over its hypotenuse. So sine of angle A will be A over C. Okay, we must have to compute for A. Compute for A. So we will take the so-called arc sine of both sides. Arc sine. Okay. And the arc sine of the right hand side will be the arc sine of the ratio A over A. To compute for A, we will take the arc sine of both sides. The arc sine of A will just be simply A. Okay, this will cancel out. Okay. And the arc sine of the right hand side will be the arc sine of the ratio A over C. So if we are now given side A and we are given side C, we will take the ratio of that one, then we'll place arc sine or tangent to the -1 using our calculator, right? So we could compute for A. Okay? And B now will be 90 degrees minus the computed value of A. Because A now will be in terms of degrees. Okay? In terms of degrees. So whatever degree that will come out for A, you subtract that from 90 and that will be the value of angle B. Okay, how do we compute for the so-called side B? We use Pythagoras principle, right? The square of the hypotenuse should be equal to the sum of the squares of A plus B squared. Okay? In any right triangle, A square plus B square is equal to C square. So if we try to compute for B, B square now will be equal to C square minus A square. And if we try to compute for B, log sup, what do you call this, exponent. You raise both sides to the 1/2. B square raised to the 1/2, these two here cancel with this. Left hand side will just be simply B. And C square minus A square raised to the 1/2 will be the square root of C square minus A square. Okay? So B will be the square root of the square of the hypotenuse minus the square of side A. You take the square root. Okay? Okay, we now know B. We now know A by using the arc sine of the ratio A over C. You subtract that from 90 and that will be B. Okay, what's next? Okay, I will try to erase this one so it will look good on the video. Right? I just show you how we arrive at the value of A to be equal to the arc sine of A over C. Okay, case number 5. For case number 4, we are given hypotenuse in A, and for case number 5, we are given two sides. Two sides meaning the hypotenuse is not given. We are given side A and side B. So if we are given side A and side B, what is being asked is actually A. Okay, and what will be B? And what will be the hypotenuse? Right? So we are just rotating, right? Okay, the relationship of A and B, considering angle A, will be tangent. The tangent of this angle here will be the ratio of A, its opposite side, over its adjacent side. That is tangent A. And taking the arctangent of both sides, the arctangent of tangent of A will just be simply A. Okay? And the arctangent of A over A will be the arctangent of A, the ratio A over B. Okay? There is an arctangent here. It is the what you call as Bolton tangent to the -1. That's arctangent using the calculator. So if we could take the ratio of A over B, we press arctangent or tangent to the -1. It falls under the second function on the calculator. We could compute for A. Right? In terms of degrees. So A now will be in terms of degrees. So if we subtract A from 90 degrees, that will now be the value of B. Okay? We have computed for A already. We subtract 90 degrees from OA from 90 degrees, and that will now be the value of B. And how could we compute for the value of C? Again, we use Pythagorean principle or Pythagoras principle. We are given side A, we are given side B, and we are solving for the hypotenuse. So C now will be the square root of A square plus B square. As usual, we start with A square plus B square equal to C square. Am I still on the camera? And we must have to compute for C. We take the square root of both sides. The square root of C square will just be simply C. And the square root of the sum of the squares of A square plus B square will be the square root of A square plus B square. We are given A, we are given B. You take the sum of the squares, then take the square root, and that will be the value of C. Okay, that's it, guys. These are the 5 cases of problems that will fall under the study of right triangles. Okay, I will repeat it before we will go for tonight. Case number 1, we are given angle A and what is given? Side C, hypotenuse. Right? Case number 2, we are given angle A and opposite side A. Case number 3, we are given angle A and adjacent side B. Case number 3, we are given the hypotenuse and side A. And case number 5, we are given the two sides, that is A and B. So what is being asked is angle A, angle B, and the hypotenuse. Okay, that's it, guys. This is Professor David J. De Los Reyes from Los Angeles. Good evening.